Okay, now we're turning to applications, simple applications of the concepts we've been talking about. And at this stage, I'm going to talk about, let's say, dot product. Then I'll write the dot product. Dot product is something we call what? Scalar product. Right. Now, what is the story here? Let's talk about work done. Let's say there's a force. Let's first of all have a point of reference here, O, the origin. Reference point, let's call it origin. Now let's say we've got a force which is going to carry a load from P to Q. Obviously, we've got 2 points like that, P and Q. We've got 2 points like that, P and Q. I'm going to just do this thing in general, then we're going to take particular points with coordinates. Out. So if you've got 2 points, that immediately you've got a vector which you can call, let's call it R, and that vector is PQ. Obviously, QP is the opposite vector to that. Now, if we look at it as PQ, then I think you can notice that this is PO. Now it's from P to O plus O to Q. And as if I put a vector here, come here and come there, then this vector is the resultant vector, isn't it? Are we together, guys? But the other way of representing that, we could have said O Q minus OP. Just try to negotiate that and see whether we can get an agreement with what I'm putting up there. Does that make sense? Now, if I've got OQ, and I've got OP, this vector R I'm talking about is same as OQ minus that. Remember what when we were doing the subtraction of vectors and segments, isn't it? Is that correct? It's fine. Now, if we're to get a force which is carrying a load from there to there, let me just draw lines here. I'll just draw lines this way. This is very ugly. Very, very ugly. Let's do it this way. That's the vector OQ. And then that's the vector OP, which I'm talking about, isn't it? And then the vector R we're talking about is this vector. Are we together, guys? Then let's write there vector R. Then a force is also a vector. Now let's say we've got a force here F, and we put an arrow there just to indicate that vector. Now, if we want to calculate the work done by force carrying a load from there to there to there, we actually use what we call the dot product. What is this? Work done will be defined this way. Work done is, when I'm using this thing, normally I want to use this symbol. I say defined by. So it's defined by this formula. It's actually F, the vector F, dot vector R, which is, according to that definition, this is the absolute value of F multiplied by the absolute value of R multiplied by cosine of the angle between the two vectors. So it depends over that force. It might not necessarily be acting in the direction of r. However, so then that's what we do. Then this is how we calculate work done. Now, if these two vectors are given in terms of components, we all know what to do, isn't it? Yes or no? We all know what to do. Now, let's now get to a particular example with a particular vector, with a particular r, with a particular what? PQ. Let's say. Let's go to, let's say, next page here. Now, this is continued example. That was the first one, was just an example to explain the situation. I think now we're all on top of the situation. Now we can take a particular situation and work it out with it. Now, let's say a force is given by this vector 3j, no, 3i, sorry, 3i minus 2j plus 5k. Then let's suppose, let's say point P and Q. Yeah, point P and Q. There I'm just writing it them roughly, but now P is actually given by this point. P is actually given by this point. 1, 4 minus 1. Remember, if P is that point, which means the vector from the origin has got its head there, or P has got that head there, isn't it? So you can write it as a vector also, if you want, isn't it? So, but here I've just given it as a point. But what I'm trying to say is that you must be able to interpret that thing in terms of a vector OP. Are we together? So you can adjust to that OQ minus OP. Remember? Okay. Now what is Q? Q is minus 2, 3, 1. So now the question is, what is work done by this force? Can we calculate that? Work done by this force from what we just discussed now. Can you do that, please? You've got your notes in front of you. There you've got that discussion in front of you. Can you quickly do that? So I'll simply write here F dot R. Now look at what I've written there. Look at what I've written there. There's a simple question which you should have asked yourself and they answered it immediately. What's the question? Look at the problem there. If you look at the problem there and look at the formula which I gave you, there's one thing which is not mentioned. What is not mentioned? Come again? Come again? But there's the information given to help you with R. Yes or no? So then the first thing will be to determine R. Okay. So I would say now, I don't want to say solution. I think we must determine R. So guys, go on, determine R. Right guys, notice this. R is actually P, Q. When you put vector given this way, this is how we do it. You can just, listen to me. Listen to me. The simplest way of doing this thing is to take the coordinates of P, subtract the corresponding coordinates of what? Of Q. So you can just say, no, Q subtract the coordinates of P. All together. Because the R at the head is at Q. So it's a quotients of P from that. So I'll say here, minus 2 minus 1. I'll get minus 3I. Then minus 3 minus 4. I'll get minus 1J. Do you get what I'm saying? Do you get what I'm saying? I'm giving you a hint of getting quickly that vector. The vector is like this. It starts at P, it ends at Q. So to get that vector, you just take the coordinates of Q, subtract the ones of R, then you just label that between there. I just minus 2 minus 1, 3, I. 3 minus 4, minus 1, J. Then 1 minus 1, that's 2. Then I get the plus 2, what? K. That's vector R. Are we together, right? Okay. Then now what do? We now got the components of R. We've got the components of what? Of F. Then what is work done? Therefore, work done is F dot R. Then I just take the components. What do I do here? I just take the components to multiply it. So it's 3 times minus 3. 3 times minus 3 plus minus 2 times minus 1 plus 5 times 2. If I'm not making mistake, this work was 3 units, like it's in 3 units of work, something like that. What do we use to measure work? Joules. So, but here we just say 3 units, but the joules can use to that. Now this is 9. This is what? 2. This is 10. So this is 10 plus 2 is 12. This is minus 9 actually. This is minus 9, and this is 3. Now it's units. Now it's units of work done. There you are done. Are we together, guys? Okay. I think our time has been eaten by the rough dogs. So I'm going to stop here. I'm going to say for today, thank you for listening. I hope you are going to make a follow-up start on this and avoid accumulating excessive work that is stressful. Thank you and goodbye. See you when you see me. The voice is Charles. This was fun.